value you can note down. Okay, similarly for the third 15 centimeters also you can note down the number of blows required for the penetration. Okay, once you have this first 15 centimeters, second 15 centimeter, third 15 centimeters and value or just the number of blows value, then you can neglect the first 15 centimeters and value and then take the summation of 15 centimeters to, take the summation of number of blows from 15 centimeters to 450 centimeters. 15 centimeters to 45 centimeters. 150 mm to 450 mm. Okay. So then that would be the standard penetration test N value. Okay. So in order to know that all these things just already we have discussed. So once you do the testing at the required depth, then you need to take out the split spoon sampler and detach the split spoon sampler like this and then collect the sample for testing in the laboratory. Okay, as you can see the different types of soils in the split spoon sampler. So this is the, and last class I gave this explanation, I think. So whenever you have the split spoon sampler inside the ground level, which cannot be observed visually, and then just you need to know 15 centimeter penetration. For that one, just generally we'll mark 15 centimeters at the ground level itself. So after placing the split spoon sampler, first you know see the ground level. So mark it. Then for 15 centimeters, 30 centimeters, 45 centimeters, you mark the distance on the rod, so that if 15 centimeters penetration can be observed from the ground level itself. Okay, so this is the field testing unit which we have in the JNTU College of Engineering. Just you can see this. This is the drop hammer weight. So drop hammer. So this weight is 63.5 and including the connections, this connection and the rope, so total accounts to 65 kg. So these are, just you can see, there is only one leg of a tripod is visible here. So the other two will be on the other side, and this rope is connected to pulley. So I have given the figure also just in the previous, no, not this one. Here you can see. So it will be connected to pulley, and then the rope, using the rope, just the hammer can be, or rammer can be pulled and then that can be released. Okay. So for mechanical means, if you want to use mechanical operator for this one, that would be better. So if you want to use labor for pulling and releasing the hammer, so you may need at least 10 people for pulling that and then releasing the, or just leaving the rope. So at least 7 to 8 members are required, and 2 members are required to hold the tripod legs. Okay, so that is the minimum requirement. Just you can see here, one person is holding the tripod leg. Similarly, just for other tripod legs also, somebody has to hold. Sometimes what will happen if the rammer is falling down, this leg may be moving in the inward direction, so that some damage may occur. So those whoever working in the site, they may get some problems. So that's why just always we'll use 7 to 8 members for pulling the rope and 2 to 3 members for holding the tripod legs. Okay, so in order to avoid this labor, all those things, generally we'll go for mechanized version of standard penetration test. So once we have the cutting edge for the split spoon sampler, at the bottom just we are connecting the cutting edge. So here the sample tube, this is the sample tube. So whatever may be the sample tube, it may be split spoon sampler or the shell belly without split. Just if you have, is there any figure in the previous case? I have shown you, I think. Wait, I'll go to this. Oh. No. Wait. it may be split spoon sampler or the core like this. So core cutter, whatever you are using in the laboratory, the same thing can be used here. But the length of the core maybe length of the core will be more than 12.7 centimeters. Usually we will use 40 to 50 centimeter length of the core. So here you can see. So this coupling is there and this is connected to drill rod. So if you have this such type of shell bay tube, this is known as shell bay tube, then also just you need to maintain certain aspects. So if you have a tube and then a cutting edge at the bottom, so you should maintain certain specifications. So those specifications are given here. So whenever you want to purchase the core cutting machine or the spoon sampler, we need to check these things. So in the market, so many instruments or this equipment will be available. So whatever is visible or whatever is there in the market, we should not buy. So there are some specifications. If the specifications are meeting or the limitations are there, so some limitations. So if those are meeting, then only just we need to purchase the required cutting edges. So for the cutting edges, certain specifications are given here in IS code 1892. Okay, so you see the connections here. So this is the sample tube. Okay, so at the bottom of the sample tube, cutting shoe is placed. So here you can see threading. So using threading, just we need to fit the cutting shoe. So once you have cutting shoe, the inner and outer diameter of the sampler tube and cutting shoe must be noted down. Okay, so the inside and outside diameters of the sample tube are DS and DT respectively. And the inside and outside diameters of cutting shoe are DC and DW respectively. Okay, so you have these symbols and we need to check the limitations or specifications given in IS 1892. So in order to purchase or in order to manufacture and in order to fabricate the cutting edge, so you need to follow first one, inside clearance, outside clearance and area ratio. Area ratio is in next slide. So inside clearance must be between 1 and 3. So how to calculate inside clearance? So inside clearance is denoted using this CI symbol, which is equal to DS minus DC divided by DC. So inside clearance, for inside clearance, sample in inner diameter and the cutting shoe inner diameter we need to use. That means there will be some difference here, just you can see here. So cutting shoe has lesser diameter compared to the sample tube. So this inside clearance is required. So small difference is there. So that inside clearance must be between 1 and 3. So how to calculate that inside clearance? So as I said earlier, so this equation you need to use DS minus DC divided by DC. Okay, check whether this CI is between 1 and 3. So if it is between 1 and 3, then you can accept the cutting edge for the soil exploration purpose. Otherwise, you can reject that. So whenever you go to the field, so such checkings will be there. Those are known as quality control checks. So those quality control checks you need to make. Okay. Then outside clearance, any doubts? I'm hearing some voice. Any doubts regarding this or regarding the previous? Any doubts?
No, ma'am.
Voice? No? Okay then.
No, ma'am.
Okay. Then outside clearance. Outside clearance is denoted by C naught. This outside clearance must be between 0 and 2. So it should be greater than 0 and it should be less than 2. Okay. So the outside clearance is equal to the outer diameter of the cutting shoe minus outer diameter of the sample tube divided by outer diameter of the sample tube. So this is the equation. So this, after calculating this, you should get the value between 0 and 2. So here also, if this condition is not meeting, then you can reject the equipment. Okay. So here, one thing just I want to discuss. Inside clearance, outside clearance, they are specifying. Why that inside clearance and outside clearance are required? If you have only sample tube at the bottom of the sample tube, just you can use the cutting shoe. Okay, so with the same diameter, you can go for the cutting shoe. So otherwise, just for this sample tube only, just you can sharpen the edges at the bottom, and then that can be used for the excavation purpose or driving the sample tube. Okay, so why this clearance is required? Anybody has an idea? Why this inside clearance and outside clearance are required? If you have any idea, just you explain. That is very simple. So if you see the diameters, and then you can able to assess. Anybody? I'm coming back to chart. So do you have any idea about the clearance? So why we need to provide the clearance? So clearance magnitude you can calculate using that formula. But why we need that? So that is also important. So simply just whatever literature says or code says, we should not agree. So there should be some logic. So to provide that one. So if there is no logic or there is no scientific background, just simply you can say that that this is not required for the equipment, or provision is not required, like that. Just Abhishek, you are saying something. Just tell me. Abhishek, you are saying something. Or if you have any net problem, then put it in chart. So why we need that inside and outside clearance for the sampler? Anybody? So once you see the figure, then you can able to assess. Anybody? That means you are not using your brains. So think and then tell me the answer. So physics is required. Okay? For any engineering, so it may be civil engineering or mechanical or computer science, anything. So physically what is happening, that is the requirement to study or to progress the you can say the subjects or anything. So why it is happening like that? What is the physics behind that? That like that, just you need to think. Okay. Now just I am projecting this. Then can you tell me the reason? Tell me the reason. I'll put side by side, just whoever is giving the answer, just I may know that.